Hi everyone, welcome. In this video we are going to talk about the learning curves or the experience curves, and mostly used in production operations management and project management. And the idea is simple. If you purchase an IKEA product and the first time it is going to take you maybe 10 hours to do the assembly, but if you do it the next time, the second time, it's going to take less than the hours. Hopefully you'll just be able to complete that project in a correct way the first time when you do it. So here are the epic failures of some IKEA project completion. And IKEA, if you see this, just send us some promotional materials, please. Thank you. Okay, so for example, if you complete a project, let's say in the first time for 120 hours, if the duration of the first project takes 120 hours, then the second one, when you double that production amount from 1 to 2, then you are going to see a constant rate of decrease in the duration. And that constant rate of decrease is called the learning rate, so which is 80%. For example, in here, if I double that project, so it's number 2, then the duration goes down from 120 to 80. Just lock that down. 80% times, I'm sorry, not 80, 80% times 120 goes down to -6. So when we double that project number 2 to project number 4, so we are doubling the, now we are the fourth product, and we are going to be able to complete the fourth product in 76.8 hours, which is 96 times the 80%, if the learning rate is 80%. So when you double the project number, the duration just decreases by a fixed rate, which is called a learning rate. So if I just drag this down to a certain number, let's say up to 64, as you can see that the duration goes down. But you also need to take into consideration that after a while this principle may not hold for large numbers, because theoretically this just goes down to closer to 0, which is not the case most of the time. So the idea originated in 1936 by T.P. Wright, and just looked at the cost of airplanes. They produced the first airplane, the cost, and then the second one, the third, fourth, fifth, and they observed something like a curve and exponential relationship. And that was 1936, and that relationship later on, I think this is 1956. Again, these are certain types of airplanes, and you're seeing here that there is a rate of decline for different types of airplanes. And we want to kind of find out what is the rate of decline for our projects, and when we find that out, then we can take that into consideration if we are, for example, completing a project, and if we need to do that project 10 times, and how many hours that we need to spend on that project, we should take the learning curves into consideration. Okay, now how are we going to find, for example, yes, we know that number 2, number 4, number 8, but how are we going to fill the gaps? Like, what is the project number 5? What is the duration of project number 5 or project number 10, 11, 12? So let's take a look at now the relationship between the project number and the durations, and then we could just insert a scatter chart. Let's just do that with a line, with a smooth line, and what we are seeing is we are seeing that exponential relationship between the duration and the number of, this is the duration on the y-axis, and this is the x-axis. This is the number of times that you complete that project. And let's now just get rid of that line and just put the points. I think it's better to just put the points now. We are going to fit a line to this, and we'll try to see what kind of an equation it is. And if I click on those points and then right click on them and then add a trend line. And we're not going to add a linear trend line. We are going to add a power trend line. Okay, so that's, and we see that it is just a right fit. So we were able to find the exact same formula for these points. And now we could just display the equation on chart. And we will just take that somewhere here. And if we want, we could just make that larger. And then we could see that. That's the relationship. Now, because we know the curve, we could just now find the gaps. We can find project number 5, 6, 7, 9, 10, 11, 12, etc. using this formula. That is what? 120 times x, which is the project number, to the exponent is negative 0.322. That is the rate of reduction. So that is not the learning rate. The learning rate is the reduction when you double the number, but here this is just showing you the rate of reduction as an exponential relationship. So for example, let's just take that this number is just rounded here to 0.322, but the numbers is not going to be as accurate as these numbers that we see here, but we can find out the values here. Let's say if I take the project number and make it, let's say 1, and then let's just put the duration, and then the duration is going to be 120, which is the initial value, times x, which is, just put in a parenthesis, or we don't have to because of the PEMDAS. So that E4 exponent, now we could maybe put a parenthesis here, negative 0.322. Okay, that's it. So the project number 1 is going to take 120 hours. 2 is going to take 95.99, which is very close here because this number is rounded. Project number 3, now we can find that, is 84.24, and then 4 is 76.79. And now we can also find 5 or 6, whatever we want, then we can find that in here. So how do we find this without fitting this line, that number, that negative 0.322, that the reduction? Let's call this 120, the initial amount, as A, and then let's call this negative 0.322 as B. So there is a formula for B, and that formula for B is the log of the learning rate and divided by the log of the 2. Okay, so it is just a constant value. Log of the learning rate divided by log of 2, and then that's it. It's this number. As you can see, it's the same thing. So we didn't have to fit a line. We know that value. Now, if you like math, now I'm going to take you to a journey. If you don't like math, you can skip that part. And what's going to happen is we'll try to find the B value in here. And how are we going to find that? So remember that our formula had the shape of formatting of A times x to the negative B. And if that's the case, we said negative b, but we could just take the b as a negative value, and it could be a times x to the b, and it is going to be the same idea. Let's just take it a times x to the negative b, and as you can see here, what's happening is, let's say if I want to find out what is y 2x when we would double that production from x to 2x, and if I do that, I put wherever I see x, I put 2x, and then I just take 2x to the negative b, then I can divide the exponents, and I can make, not divide, but separate the exponents, 2 to the negative b and x to the negative b, and reorganize it, and I can see that it is 2 to the negative b times the same exact part for yx, so that is 2 to the negative b times yx. So that means when we go from yx to y2x, or y2x to yx, if I just get the ratio of those two values, I can see that the ratio is fixed amount, that's 2 to the negative b. So what does it mean? It means that here 120, 96 over 120, 76.8 over 96, 61.44 over 78.6, these are all the same numbers, okay? The same number. And in that case, let's just take a look at here. That divided by this, okay? So 0.8 and 0.8, which is, we already did that, right? So we kind of did that before, and we just used our formula by just multiplying that by 0.8. Now we are just dividing, and we are just finding the same number. Now, if that's the case, let's call that 2 to the negative b that we found, right? That was 0.8. Call it the learning rate, L. And then from here, we are going to find what b is. We take both sides, the log of the both sides, and then that's ln of L and ln of 2 to the negative b. Then the exponent comes in front, ln L is negative b, ln 2, and from here b is equal to negative log of L divided by log of 2. And you can use the natural log or any log that you want, any base, it is going to be the same thing. So once you find the b value, then it is going to give you the the rate of reduction, and from there you could just simply put your formula in, a times x to the negative b, and that's it. So let's just find that b in here without, so we're able to find that, and let's, I just punch in the formula, right? Negative L and L over L and 2, and as you can see here, I didn't put the negative here. If I just put negative, that's 0.32, then I need to just make it a negative. So just know that you need to divide the learning rate, log of learning rate, by log of 2, and you are going to find the b value, okay? And then you are going to take the negative of that in your formula. That's just to be concise, make that just a positive number. Okay, so this is going to be a negative number, and this is going to be a times x to the negative b, x to the negative b. So which is here a times x to the negative b. Okay, in that case, what we could do is we could directly put our information, and we can say that for project number 1, 2, 3, we can find all those durations. And if A is 120, and then B is, we can find that from log of 80% divided by log of 2, and just make put a negative there. Okay, so that's 0.32, and then we can just put the duration as the initial rate, 120, and fix that with a dollar sign, times x to the negative b. Okay, so that's 120, and then you can just, oops, what happened here? E2, I need to put b, and I need to make a, fix that one too. That's it. Now we have to just run that. Okay, so now we are able to see those durations, and durations are going down, and it's just reflecting that learning rate. So if I change my learning rate to 90%, and now I see again a decline, but now when you double, the rate of reduction is only the 90% of the original. So it's this, the rate is only always 90%. And if my duration for the first project is, let's say, 10,000 or 1,000, and I can see them directly here right away, and I can see their relationship. How can we use this information? Let's just do that very quick. And for example, let's say you are completing a project and you need to give a bid to the project, and you are going to complete the same project for 8 times. Let's say it's kind of a custom made product, and you need to just produce it using project management, and then you need to do that the same one for 8 times. Maybe a special factory construction in different parts of the world, something like that. So there is going to be, let's say, a fixed R&D cost, fixed material cost, a labor cost per hour, and now we need to find the labor cost for all 8 projects. And how do we do that is we need to find first time for the 8 projects. Assume that the learning rate is 80% and the time for the first project is 100,000. Then we find what B is, okay? And let's just be concise and just put a negative there. So this is your B, and then number of projects is 8. Time for the 8th project is what? The time for the 8th project is, I could just use the B, but I just used the log of E2 over log of 2. The 8th project is 51,200. What is the time for all 8 projects? In that case, what I have to do is I have to just go to my sheet here. Duration of the first project is 100,000. Let's just put just make it like a number, and formatting. Learning rate is 80%, and the time for 8 projects is, right, 534,591.4. I can just put here, somewhere here, I can make this cumulative duration, and the cumulative duration is going to be what? First, I'm just going to make this equal to that, and then plus this, right? So that's it. And then double click in here. So the time for 8th project is 534,591. I punched that in here. I found that time for all 8 projects. And then if this is the time, if the labor cost for 8 projects is then going to be $300 times the time for all 8 projects. And then I'm going to have my total, this is the total direct cost, which includes the R&D, material, and the labor cost. Assume that we will put 20% overhead on top of that, and that's the total cost. Assume that we will put 25% profit on top of that, 53,000, and then if you just add them up, 267,566,109, which is your bid amount. And you can just take that bid amount if you were able to kind of figure out your learning rate in the best way, right? So if this is correct, this number is correct. If this is not correct, this is not going to be correct. So garbage in, garbage out, and you can see that in here. So assume that if you want to be just a little bit more conservative in the number, if I just make the learning rate to be 90%, and then I could just take a look at here. This learning rate is 90%. If the learning rate is 90%, my 8th project is going to be 657. Let's do a very quick. I don't want to play this here around just the number. I can just do a Vlookup. Okay, I can do a Vlookup. The lookup value is what? I'm gonna look for 8, and from where? I'm gonna look for this table. Okay, and then I'm just going to put $signs in there, and then I'll go back to my sheet, and this is the first column of the table, second column of the table, and the third column of the table. Now I'm going to say that once that's done, column index number is what? The third. We'll just take the third column, and the range lookup is an exact match. And once we're done, time for all 8 projects, we'll find for E7 under sheet 2. Let's just not sheet 3. I don't know why it just changes. And 657. If you don't want to put something like this, what you could do is, instead of referring there, you can highlight this range, and then you can just name it my table, okay? And then you can go back to here, and then instead of just putting that sheet there, just call it my table, and voila. Now you have the time for all 8 projects. If I just change this to 10, I find the time for 10 projects, etc. So we can just reflect that information, and the learning rate here, we can just take that and make it equal to the learning rate we have here, so that we don't have different learning rates in 2 different places. I think this video happened to be longer than what I would expected. 20 minutes. Oh my god. I think the people are not going to watch all of them, but this is a complete coverage of the learning rates for production operations or project management. Thanks for watching.